Hello and welcome to the Predictive Analytics series on the 2014 Indian elections. I'm Joydeep Das, the Chief Strategy Officer at Fuzzy Logics. With me, I have Partha Sen, CEO of Fuzzy Logics. What we're going to do today is use various mathematical and statistical methodologies to look at the various variables that come into play during an election, especially for a multi-party democracy like India, on how we can predict that in a very scientific method. So with that, I will let Partha explain a few basic concepts around what we're going to use, and we'll go from there. Partha?
Hello and namaskar. As Joydeep said, we are actually going to talk about predictive analytics in the context of Indian elections. And the way we start is that we talk about opinion polls per se and how opinion polls can be used for forecasting the results of elections. And what do you have to consider when using opinion polls in the context of a multi-party democracy with a parliamentary system of governance in India? And then, this will be our part one, and then we will show how we are using this methodology for actually forecasting the results. So with that said, let me ask you something. Have you ever participated in an opinion poll?
Yes, I have, but mostly at a local and county level. And I understand the concept, and from what I believe, it's a very common method used across the world in many of the election scenarios, including the one that we use in the United States.
Indeed. And opinion polls are, an integral part of the democracy now. In any country where you have elections, you will see opinion polls being conducted. And we have seen opinion polls. Actually, in US, we have opinion polls every single week on the ratings of the president and many other things. So, in any case, in an opinion poll, we have a randomly selected sample of the respondents or voters. And we go to these voters and ask them for their voting preference. Now, it's a randomly selected sample, so obviously you're not polling all the people in the electorate. You are polling only a certain percentage, a small percentage of the people. Now, after you have obtained the voting preferences of the people, then you have to somehow project it on the entire population and see what the results will look like, within the bounds of sampling error, of course. So that's what opinion polls are about. Now, as you know, there are a lot of pitfalls with opinion polls. The first problem is that a randomly selected sample may not be representative of the population.
So what the concept that you're talking about, the pitfalls, so is this something that is quite prevalent, or is it isolated to some scenarios?
Well, it's not quite prevalent. I think that it could become prevalent if you are not carefully selecting your sample. It could be a big problem if you are not independent, if you have some sort of bias inherent in the sample. So when selecting the sample, you have to pay attention to the demographic composition, the composition of the population by age, male-female ratio, all those kinds of things, and potentially also adjust your sample to represent the proportion of various groups in your population. One of the common things that happen with opinion polls is that you select a sample, and that sample does not have enough representation from, let's say, thickly populated areas. So, you from Mumbai, in Mumbai there are certain pockets that are very thickly populated. So if you are actually missing the respondents from those thickly populated areas, they're not represented properly, the outcome of your opinion polls are probably going to be wrong. Now, another problem that you see often is that sometimes people do not believe what purpose you are conducting this opinion poll for. So they just don't believe you. They're suspicious of your intent, and they may not tell you what they really think. They may not give you the correct answer. So obviously, if they're not giving you the correct answer, then the outcome of your opinion polls are going to be wrong. And lastly but not the least, we have seen this on several occasions in the past, including several opinion polls in US. Races that are close to call, or close contests. In those instances, opinion polls could actually be wrong. 1% swing or a 2% swing could actually take it either way. And actually, a 1% swing or a 2% swing on the day of polling is quite possible.
Yeah.
And we have seen this several instances in the past, like for example, voting in Ohio and in Florida, where it was very, very difficult to actually call the race.
Yeah. So when you look at these various factors, I'm assuming that it's not true that all of the factors apply in all of the regions where the polls are conducted. There are variances there, and the way they pick whom they want to poll is supposed to be random, but all of these factors come into the play.
Yeah, definitely. And I think that sometimes what pollsters do is that they have a sample of people and they call them, and they might actually go back to the same set of people. It's more for convenience.
Yes.
And whether, that may actually have some sort of a bias, some sort of a continuity bias in that sample, and that's something that we have to, account for.
Great.
Now, a lot about opinion polls, but in the context of India, opinion polls are a little more complicated. That's because it's not a presidential form of government where you have a few candidates. Practically, you are having elections in 543 constituencies for the Lok Sabha. Now, something that you have to keep in mind is that the political reality in different states in India is different.
Yep.
So I'll give you an example. So you have West Bengal, where you have Trinamool Congress, the Congress and the left. And the very neighboring state, Orissa, you have Naveen Patnaik's Biju Janata Dal and the BJP and the Congress. So between 300 kilometers or 400 kilometers, you are seeing these kinds of differences. So in the context of India, you have to conduct these opinion polls on pretty much on a state-by-state basis. If you were to conduct a national opinion poll and try to project the results on the entire nation, I think that you will be grossly wrong.
Yeah. So the variations and the variances are so diverse, and not just diverse but significantly different from state to state, that it requires a lot of careful analysis at a state level.
That's correct. And the demographic composition as far as age groups go, they may be the same. The male-female ratio, that may be the same. But what is dramatically different in India is the political alliances that you see from state to state to state. And also you see that in India you have certain states where you have regional parties that are very powerful. For example, the DMK and ADMK in Tamil Nadu, Trinamool Congress and the left in West Bengal. You have the Akali Dal in Punjab. So you have to account for those things.
Yes.
That's something that I wanted to actually state regarding the context of opinion polls in India. Now,
so going beyond opinion polls now, so you're going to give us a more scientific approach to these predictions then, or is it going to be an extension of opinion polls, or is it going to be something significantly different?
Well, what I will do is I will talk about a couple of different methods. So you have to understand that when you conduct an opinion poll, you have a sample, and from that sample you have obtained their voting preferences. Now you have to somehow translate these voting preferences into number of seats that they will win. So there's one method called the cube law that have been applied by statisticians and psephologists in the past. Now what the cube law states is that if you have two parties, let's say you have two parties, party A and party B, and party A gets a certain number of votes or certain percentage of votes, and party B gets certain percentage of votes, then the number of seats to be won by party A will be the percentage of votes cubed for that party divided by the sum of the cubes of the percentage of votes for both the parties times the number of seats. So, I mean, it's hard to actually talk about mathematical formulas in words, but this is an example. So I have three parties here. Party A gets 40% of the votes, Party B gets 35% of the votes, and Party C gets 25% of the votes. Well, what happens is that we are actually using these equations now. So we have the cube value for Party A, the cubed value for Party A plus the cubed value for Party B, and the cubed value for Party C. And let's say we have 100 seats. So we multiply that. So Party A is projected to win 52 seats. Party B is projected to win 35 seats, and Party C is projected to win 13 seats. So this is the calculation. Now this applies for the first past the post system like we have in India. In a proportional representation system that they have in certain countries, these obviously will not apply.
So what you're saying is that this is a much more scientific way of projecting the seats in an election, however, under certain conditions. And so would you characterize those certain conditions not applying to the Indian system, or applicable to the Indian system but not going to be as relevant?
Well, I think that if you have to consider the performance of cube law, it works well. It has performed reasonably well in UK. You have a sort of uniformity from different parts of UK, Southern England versus the Midlands. You have two parties, the Conservative Party and the Labour Party. Of course, now you have the Lib Dems, and I haven't studied how well it performs with the Lib Dems coming into the picture. However, in a multi-party democracy, cube law does not work well. The empirical evidence will prove that it has not performed well. Actually, even in Canada, it has been studied. The performance of cube law has been studied in Canada, and even in Canada, where there are differences between states, the states on the eastern seaboard versus the one on the west, on the middle, there are some differences, and there it has been observed not to do well.
And the Canadian system has a lot of similarities with the UK system in terms of the parties and the way they're set up, except that there are some regional or provincial parties that are significantly different.
Yeah, I mean the system is similar to the one we have in India, and in Canada also they have certain regions where they have regional parties where the regional parties in certain regions are quite strong.
Yeah.
So some similarities. Now, one thing though that is questionable here is that there is no science behind cubing the voting percentages. There's no science behind it. It's an empirically derived or heuristically derived formula, and that could be a problem. Like, why should we have cube values? Why not squares? Or why not raise it to the power of 10? Something like that. So anyways, I mean, this is a method. But in a multi-party democracy like India, the empirical evidence is very weak. So we have to look for some alternatives. So what we have done is to use an alternative method, or at least investigate an alternative method. And here the objective that we have in this entire predictive analytics series for Indian elections is that we want to make predictions. True, but we want to be transparent. So there are lots of opinion polls that are being conducted, but nobody is telling you what is the methodology that they are applying. We want to say, here is the methodology that we are applying, and subsequently use that methodology for predicting.
So what you're telling me is that what we have seen so far, opinion polls and cube law, has, of course you said opinion polls has its severe limitations, and cube law has its limitation in the context of India. What we then need is a scientific methodology that allows us to predict it, but also something that we can actually explain and be very transparent about in our method here, so that people can understand the actual science behind it.
Yeah, that's absolutely right. We want to make predictions, but we want to make predictions based on a method that is transparent to everybody.
Yeah.
The method that we are using is called raking. And if you want to be really fancy about it, you can call it iterative proportional fit. I'll try to explain it with an example. So this is the result from a past election. Let's say that there are two seats, 1 and 2, and we have three parties, A, B, and C. Obviously, I don't want to name the party. So we have the totals here, the total votes for seat 1 and seat 2, and we also have the totals for the parties. So party A, party B, and party C. So this is from past election,
Yes.
right? Now let us say that the voting share, the share of votes changes. So another election is held in 4 years or 5 years, and you are expecting that the shares of votes will change for party A, B, and C.
Share a vote, we need to focus then on this last row.
That is the last row. So that's what we want to focus. Now, we are also making one assumption here, which is, by the way, an incorrect assumption, but we want to make an assumption here just for the sake of this example. So the assumption is that the votes in each seat, seat 1 and seat 2, will be the same. Right. Now, obviously, if you take a real election, the votes will not be the same because you have population growth and you will have more voters, but you can adjust for that. You can say, well, I have 7% more voters this time, so I will have 7% more votes in seat A and 7% more votes in seat B.
So basically, the assumption may not account for certain, maybe small factors like migration of population and stuff like that.
Yeah, I mean, I think that, look, those factors are always going to be there. So if you have elections on a good weather day and the subsequent elections where the weather is very bad, then some people might choose to stay indoors.
Yeah.
You could also have factors where fringe groups actually threaten people not to vote. So that may or may not have an effect. And then obviously in certain elections you have high profile elections in a given seat, the turnout might be very high. So those obviously will come into the picture.
So factors also specific to the election day, basically.
Yeah, factors specific to the elections will be there. But let's say the voting shares change, the share of votes change. So now we have this scenario where party A actually is going to receive 35%. Party B is going to receive 33% and party C is going to receive 32%. Now, what we have to do is to adjust these votes in each seats so that two things happen. First, that the percentage of votes for party A, B, and C actually match these prescribed vote shares. And the second thing that has to happen is that the total votes for seat 1 and seat 2 have to match these total votes that we are assuming for each of these seats. So this process is carried out iteratively. So you iteratively adjust the votes for each party and each seat till you can actually come to these values.
The totals
should stay the same, and the total votes should actually be representative of the vote share.
Basically, the individual cell values will have to be adjusted until they match up the totals.
Yeah, that's exactly right. That's the individual cell values have to be adjusted till you get those totals.
Yeah.
So it's a computationally intensive algorithm, but with modern computers and computing power that we have available, this can be easily accomplished.
Yeah.
So now, we can talk about a lot of different methods, right? So we can probably go and find literature on 5 different methods other than these 2 methods that we talked about. But in theory or in literature, they could look very good. The rubber meets the road is when you apply these methods to past elections and see how well they perform.
So when you picked the raking method, was there a consideration for these other methods that are theoretically attractive, and did you get a chance to look at them with compared with past results? I mean, this is a question I'm assuming many of our viewers will have, is why this method and why not others?
Well, I think that again, you have to. Well, first of all, yes, we did consider other methods, but the thing that you have to understand is that a method is as good as the results that you can obtain from it. So what we did was we took the results from 1999 and projected them on 2004 based on the voting shares or the share of votes obtained by each political party in each state. So we did this exercise for every single state separately. Now, when this projection was done, we did consider certain things. First of all, we did consider the increase in the number of electorates in each state separately. So now in each state separately, the population growth is different in India. Like the states in Northeast, they will have lesser population growth than some of the more densely populated states like Bengal or Bihar.
So it's back to the original premise where state-wise there are a lot of variances.
State-wise there are things that have to be taken into account, right? Also, another assumption that is made here is that the voter turnout is the same in each constituency in each of the states. So let's say you have a given constituency. Let's pick my state in Jharkhand. You have Ranchi, and let's say they have 65% turnout in 1999. We are making an assumption that in 2004 also the turnout will be the same. So let's say in hindsight, let's say I knew what is the exact percentage of votes obtained by each party in the 2004 elections, and I were given the results of 1999. Can I take the results of 1999, use the percentage of votes polled by each party in each state, and project the results? So that's exactly what we have done.
And that's the raking concept.
That is the concept of raking.
Explained earlier. One question though is that as you look at these state-wise information, it appears to me that no matter which method you choose, these variances that you talked about, or the assumptions actually that you talked about, is going to apply no matter where. If there is a change in voting patterns, if there is a change in the election day. So I don't believe that this method will be penalized more than any other method with respect to those variances.
Well, this method will not be penalized more than any other method, but I think that some of these things are out of your control, and they will, in a forecasting method, they will cancel each other out, right? Okay. So in any forecasting method, you are bound to make some errors. And the beauty of the forecasting methods is that you do have error cancellation. So you may be wrong in one place, but you will have you will be wrong on the positive side.
In aggregate,
so in aggregate, you should be okay. So the methodology, can be wrong here or there, but overall it should be okay. Now, it is rare though, and sometimes I do get asked that question: that can your methodology be completely wrong and still come up with right results in an aggregate? I think that in the context of India, if you are wrong in all the states, and then you have the right results for the whole country, that is extremely unlikely.
Right. Yeah.
Extremely unlikely. By the way, what we did here is that we again performed this projection from 1999 to 2004 for every single state, or at least the major states. Not every single state actually. We did the projection for all states having more than 10 seats, and the results are here. So
states with significant amount of representation.
Yeah, so a significant amount of representation. Look, I mean, if you are actually picking a state like, let's say, Manipur, 2 seats, or Arunachal Pradesh, 2 seats, and you are right on both, no big deal. You're wrong on both, no big deal, because it is not statistically significant enough
to make
sample
a
size.
Difference, yeah.
So we actually performed this exercise for all the states that have more than 10 seats. The exceptions were Jharkhand and Chhattisgarh, because Jharkhand and Chhattisgarh were not in existence in 1999. They were newly carved out states, Chhattisgarh from Madhya Pradesh and Jharkhand from Bihar.
I think just to bring back our viewers to the table here that you're going to explain, what you're doing is taking data from 1999, applying the model to 1999 data and projecting for 2004.
That is correct.
And then comparing with the actual results of 2004.
That is correct.
And just so that our viewers are aware that at this point we have not yet come to the 2014 projections by any means.
Yeah, that's true.
Explanation
yeah,
of methodology.
Yeah, thanks for clarifying that. So, see, what is happening here is that we have the state of Andhra Pradesh, 42 seats. Yellow, this is where we have our projected wins for 2004, and here we have the actual seats won. So, if you look at Andhra Pradesh, we are actually projecting that UPA will win 35 seats, and NDA will win 6 seats, and the actual results are 5 went in favor of NDA, 34 went in favor of UPA. Let's take Karnataka. So here we are off, and that's why I picked Karnataka. So here we projected 13 seats for NDA, 11 for UPA. The final results were that 18 for NDA and 8 for UPA. We take Maharashtra. So we have 29 for NDA, 17 for UPA. The final results 25 for UPA and 22 for 25 for NDA and 22 for UPA. So there are variances. It's not that
back to your point about them washing out.
Yeah, there will be some error cancellation. But even with the error, I mean, even if you consider individual states, you see that it's pretty close. Rajasthan pretty close, Tamil Nadu pretty close, Uttar Pradesh is a big state, 80 seats. So look at the projections here: 9 for NDA, 14 for UPA, 35 for the Samajwadi Party, and 22 for the Bahujan Samaj Party. The final results were 10 for NDA, 12 for UPA, 35 for Samajwadi Party, and 19 for the BSP.
In many ways, this is actually, accuracy is very, very good, because it's also more statistically significant because of the large data set or the electorate that you have from Uttar Pradesh.
That's correct. So, well, I mean, that doesn't mean that if you are correct in Uttar Pradesh, you will be right in the whole country.
That's true. The variations again between states makes a difference.
Right. So I'll put the conclusions. I'm sure that our viewers will agree with the conclusion that.
What's really astonishing in that conclusion, as you drive home the point, is how accurate even the totals are.
I mean, after all, if you are reasonably accurate in each state, then you will be accurate. So you have 155 for NDA, 160 actuals, 184 for UPA, and that actually
matches
exactly. Right? So and it's quite accurate.
It's quite amazing, actually, if you look at it.
So one question I get asked is that why did you not do this exercise, taking the 2004 results and projecting them on 2009? Well, in 2009 there were redistricting or a redrawing of the constituencies in India for the Lok Sabha elections. So I cannot take the data from 2004 and try to project it on 2009 without actually going through the exercise of adjusting the voting patterns based on the delimitation. Obviously, I don't have that data available, so we were sort of hamstrung to be able to perform that exercise. We wanted to, but we could not get the data. It will require us to get data at a much more granular level, and that unfortunately we could not get our hands to.
But then, should we be worried about the 2014 projections then with similar scenarios, or
does redistricting between 2009 and 2014?
So that's great. So we can hope to look forward to something like this.
Yes, hopefully. So the method. So now coming to the forecasts for 2014. So clear that we are going to use iterative proportional factoring based on the data from 2009.
So again, in other words, the raking method.
That's correct, the raking method. Now, where do we get the vote shares? We don't know how much the BJP and the alliance, the NDA is going to get. We don't know how much Congress is going to get. So we have to rely on the opinion polls that are being conducted in India. So there are a number of...
do have a role to play here.
Opinion polls do have a role to play. It's the methodology. So what we are bringing to the table is the methodology.
Yes.
We are obviously taking the data from all the different opinion polls. And then we are taking an average. So hopefully, by taking an average, we are eliminating any sample bias that an individual opinion poll might have. Or sampling error that an individual opinion poll might have. So, in the last presidential elections, it was studied that if you were to take the results of the individual opinion polls and take an average, you would do better than any of those individual opinion polls.
So this is the US presidential election.
That's correct.
Right.
That's correct. So we are also accounting for the pre-poll alliances that have happened this year. And some of the alliances that were there in 2009 are not there anymore. So you have new alliances. So we have factored those in. For example, in Bihar, the BJP has an alliance with Ramvilas Paswan's Lok Janshakti Party. So we have accounted for that. In Tamil Nadu, the BJP has put together an alliance with MDMK, the PMK, and a host of other smaller parties. So that has been taken into account. We have also taken into account that in the last elections in 2009, DMK and the Congress actually fought the elections together. That alliance is not in existence anymore. So all those factors have been taken into account, and then we are performing this projection or this forecast. Now, another thing that is interesting, and this is something that we will outline in part 2, is how sensitive is your forecast to change in vote percentage. So let's say you have party A or party B and party B and party C, and party A, based on these opinion polls, let's say it gets 37% votes. Now, if you change that forecast from 37% to 38% or 39%, what happens? So that is also something that we are actually looking at. And, in the context of certain states like Kerala, it has great relevance, because a 1% swing can actually alter the composition of the number of seats won by the LDF versus the UDF.
That's fascinating, because that will be really, really interesting to see how well that goes. And maybe it is quite the opposite is true in some other states where large changes don't affect the actual predictions as much. But I think what's another interesting part about what you said so far is the fact that all of these methodologies that you have applied has not only shown that with with less variances in terms of everything that you accounted for between 1999 and 2004, the accuracy is very good, but also the fact that this is very, very relevant for what we are about to see in the coming elections, especially with respect to all of this alliances changing. It's quite complicated taking account all of that, but I think what I really liked also in the method that you presented was that if new parties are born, new regional parties are born, even at a national level, if something like the Aam Aadmi Party or something like that, they are also accounted for, because initially they can be put into the others category as well and accounted for. So that's interesting.
Well, that is interesting, and when we come to the forecast for Delhi, we will talk about that. But what we have done in Delhi is that we are actually taking the data for from the last assembly elections and using that as a proxy for 2004, because you know that the Aam Aadmi Party actually got a significant percentage of votes in the assembly elections, so that has to be accounted for somehow. Now, one other thing I wanted to point out is that when we are going to do the forecast, we are actually going to do the forecast of the number of votes polled by, or that we are projecting to be polled by every single party not at a constituency level, but at an assembly segment level. So, for example, in Uttar Pradesh, every Lok Sabha assembly constituency consists of 5 assembly segments. So, we are actually going to forecast for every single assembly segment, then sum up the votes, the projected number of votes, and thereby find out who the winner, the projected winner is going to be. So it's a pretty elaborate method, and one of the things that we have to appreciate is that today we can have all these things at our disposal, at our fingertips, this type of information because of the advancement in information technology. So we really can perform very complicated calculations and tons of these calculations very quickly.
Okay. Thank you, Partha. I think this has been really, really enlightening, and I'm looking forward to the next discussion where we are actually going to go and apply these methodologies to real data and take a look at how we can predict the 2014 elections. Thank you.
Thank you, and I really look forward to presenting these results in our next series.
Yeah, absolutely.